The purpose of this video is to demonstrate how to perform hypothesis testing on a population mean. We're going to use homework 10.3, problem 10 as our example. It states, a company produces ball bearings which have a mean diameter of 7.33 millimeters. After replacing some parts in their production line, the lead engineer wants to check to see if there has been a change in the diameters of the ball bearings being produced. A sample of 38 ball bearings is checked, resulting in a sample mean diameter of 7.27 millimeters with a sample standard deviation of 0.17 millimeters. Test for evidence that there has been a change in either direction in the mean diameter of the ball bearings. Use a significance of alpha equals 0.5. So the first step is let's document our null hypothesis, which says the mean equals 7.33. Okay, that would be status quo. Our null or our alternate hypothesis would be mu is not equal to 7.33 millimeters. The other thing we need to take away from this problem description is that we have a sample standard deviation. There is no population standard deviation. Therefore, this is going to be a t-test. And just to emphasize the not equal sign for the alternative hypothesis, it's because they're looking to see if there's been a change in the diameters of the ball bearings in either direction. Okay, so that would tell you not equal to, which means it's a two-tailed test right here. So let's document our level of significance, which is alpha equals 0.05. And then on to our descriptive statistics. Our mean is 7.33. Our X bar, that's the sample of 38 ball bearings. Those diameters on average are 7.27, and the standard deviation is 0.17. All three of these numbers are in millimeters. Our sample is equal to 38. Step 4, we want to calculate our test statistic. For a t-test, we're going to use x bar minus mu divided by the sample standard deviation divided by the square root of the sample size. So that is equal to parentheses x bar minus 7.33 close parentheses divided by parentheses. Let's go with sample standard deviation divided by the square root of n, and we need one more parentheses, and our test statistic is minus 2.176. Okay, so it's less than the mean. Now we want to calculate the p-value associated with this test statistic. And so because this is the two-tailed test, we're going to use the following command right here. t.dis.2t, absolute value of x, and degree of freedom. For this command, note there is no cum. So we're going to hit t.dis2t. Okay, we're going to hit absolute value. We're going to plug in our t statistic. We're going to come up here between these two parentheses, comma, and we need degrees of freedom, which is, which is 38 minus 1 is 37, and enter. Our p-value is 0.0360. Okay? The level of significance is 0.05. So 0.0360 is less than 0.05. That means we would reject the null hypothesis, reject HO, stating there is sufficient evidence that the diameters have changed since the production line process changes. That concludes this video.